Hello, today the lesson is on periodic table. So I'm going to give you a little introduction to this awesome little tool that we use in chemistry. You're just going to get a little brief insight into the history of the periodic table, and then I'm going to talk about the function and the parts of the periodic table that you should be familiar with at this point. And as the year goes on, I'm going to uncover more and more about this periodic table. The actual shape, the fact that there's spaces in here in this empty space, there's a reason for all of that. Okay, and we'll talk about that as we go through. It's not that it just looks pretty cool this way. It's actually got some function to it. All right, so first of all, before we get too far into the actual periodic table, let's go back in time to 1896. All right, this little handsome gentleman right here with the nice clean-looking beard is Dmitri Mendeleev. And Dmitri was a Russian chemist, actually very poor, very poor Russian at the time, and his mom didn't have very much money, and his dad wasn't there and stuff. So he loved chemistry, loved science, and his mom really wanted him to study. So she would walk him through the Russian snows to school. Anyway, he had a pretty rough life, a pretty rough background, but he did end up becoming a very, very popular chemist. And again, there's some cool stories here. But anyway, he's very intimidating looking, and what he did was he was the first one to come up with a way of arranging the elements in a sequential way. Now, scientists were trying to do that. Here's what a number of elements that they had back in those days. They didn't discover all the elements yet, but what Dmitri found was that if he arranged the periodic table based on the properties of the elements. Now, there were a number of people that tried to come up with other systems, and actually there was one based on music, believe it or not, which is kind of funny because there is something with the number 8, like in music there's an octave. Well, in chemistry there is something to the number 8, and we'll talk about that a little bit later, but the point here is that what Dmitri Mendeleev did was he was the first one to try to put these in a particular order that made sense and actually had some function to it. Now, back before the Mendeleev was there, you had to memorize everything about all these individual elements. The beauty of what Mendeleev did is by putting them in groups, these elements had some very similar properties to them, and they all kind of fit in. So it was a very, very brilliant way of doing it. He was very good at organizing information and very good at organizing, the various, data points that they had. He was very good at playing card games, and what he did was he actually put all the symbols, and then he also put all the properties on the cards, and he kept arranging them until he finally settled on an arrangement that was best suited by average atomic mass. Now, the modern periodic table, the one we have today, is not arranged by that. So Mendeleev's table is not perfect, because obviously this is not what I have hanging on the walls in the school. Well, it did work, and if you notice, there are some patterns here: hydrogen, lithium, and sodium. Those are all in the same groups. Beryllium and boron. Instead of it going up and down, his is going left and right. So his table was great. Now, this is the big reason why he gets credit for this periodic table, is that he left spaces in here. He left empty spots for elements that hadn't been existing yet. They hadn't discovered them. So one particular one is this one that comes after silicon. It's called ecosilicon. He called it that. And he not only predicted that there would be a new element that would fit in this spot, but he also predicted the properties, which is pretty bold. He also, not only that, oh, by the way, when they did discover this, it was called germanium, the properties were almost right on the money. I mean, very, very close to what he predicted. He also said that he thought that this atomic mass was off. He thought that this atomic mass was off. And it's why there's little question marks here, because he disputed the data of the time. And again, that's a pretty bold statement to make and say that all these scientists are wrong. So Mendeleev was given credit for doing that. And again, when they went back and looked at the data, Mendeleev was right. And who actually wants to go back and tell this guy, you're wrong? And one last note on Mendeleev before we move on. He was quite the ladies' man back in the day. I am not kidding you. He was super, super famous in Russia for developing this table because everybody was using it. I mean, it was a worldwide phenomenon. This periodic table became a superstar in Russia. Is actually on their money, and I believe he still is on the money. He was at one point. Okay, since Mendeleev's table is not completely correct, if we look at the new one, the more modern table, we don't have them arranged by atomic mass. They're not by average atomic mass. The periodic table, you probably know, is based on the atomic number. And this was done by an English chemist who realized that Mendeleev's table was good, but there was just some faults in it. There were some things that didn't quite match up. And the problem with Mendeleev was that he didn't know about atomic number. The proton hadn't been discovered. 1896 at the time Mendeleev came up with that table, they hadn't discovered the proton yet. So therefore, there was no concept of an atomic number. So Henry Moseley came by later in the 1900s and rearranged the periodic table by atomic number. Now, the sad thing about Henry Moseley is that we don't really know what else he could have contributed to science, because he ended up dying in, I believe it was World War I. He ended up passing away. But you know, war just kind of does it. It gets kind of in the way of scientific progression. So anyway, back to the periodic table. What you need to know is this is the general periodic table you're going to have. The atomic numbers at the top. It's a number here. We've already talked about that. The chemical symbol and average atomic mass at the bottom. And it looks like it's arranged by average atomic mass, but you will find some discrepancies. And I always forget where they are, but there are quite a few in here. If you start looking at the numbers, they don't always increase by average atomic mass. Pretty much correlates for most of the elements, but there are quite a few that do kind of go up and then back down. Anyhow, so let's go ahead and take a look what you need to know. First of all, going up and down on our periodic table are groups or families. Groups or families, whichever you want to call them. I'm not going to sit here and name them all, but you should know what they are. Okay, this is your alkali metals. Okay, those are alkali metals. You've got your alkaline earth metals. Okay, we call these the transition metals. These are your transition metals. All right, I'll just label a couple of these here. And these are the different families that are on here. And you should know the names of all these. Okay. Then there's the boron family, the carbon family, the nitrogen family, the oxygen family. So these are just named based on the elements at the top of those groups. Okay, so boron, carbon, nitrogen, oxygen family. Here we get back to some strange names. I guess I'm writing them all in here, aren't I? These are called the halogens. And then, of course, everybody knows the last group, that's supposed to be an S there, is the noble gases. So this is your noble gas. Okay? All right, and then this would be your alkaline earth. Okay, so there's your alkaline earth metals, alkali, halogens, noble gases, and so on and so forth. So, going up and down, the columns on the periodic table are the groups or families. And by the way, this group here, you really should split your periodic table. You should cut it right here at this point, and you should separate it out. This group gets embedded right in here. So this is your inner transition, because you should put it inside. The problem if I did that is that it would go through the boundaries of my page. This would fly off the page, this would fly off the page. So in order to make it fit on a piece of paper nicely, we have to have the transition metal, or the inner transition metals, removed and put down here at the bottom. Okay? Alright, and then going horizontally, left to right on the periodic table, are called the periods. And this is where the periodic table gets its name, because if you go across the periodic table, you're going to end up with repeating patterns. These are very, very reactive metals. Then as we go from left to right, the reactivity starts to decrease. But as we start to get further to the right, we get an increase in reactivity. Chlorine is extremely reactive. Sodium is extremely reactive. Potassium is really reactive. Bromine is really reactive. So we get this repeating pattern. So if I go from left to right, they get more reactive, and then they get less reactive in the middle, and then more reactive, and then not reactive, and then it starts over again. That's why it's called the periodic table, because it keeps repeating that same pattern over and over and over again. All right? So periods are here. Now, if I were to number these, this would be 1, 2, 3, 4, 5, 6, 7. Sorry about the color that I should have chosen, but you get it. I think you can see that. So since I'm plugging this at the bottom of these two rows, these guys here are going to be numbered 6 and 7 as well. So we would say that this group here is 6, and this one here is at period 7. So you kind of have to envision. It's going to be important in the second semester when we start talking about electron configurations. So you should have those in that area there. Now, thing about the families and groups, by the way, since these keep repeating themselves and we keep getting this pattern going back and forth across the table, we find that everything in the same group or family reacts very similarly. So sodium reacts kind of like potassium, kind of like rubidium. Fluorine reacts just like chlorine, just like bromine. There's going to be slight differences, but things in the same family are going to have the same chemical properties. And this is the beauty of the periodic table. Instead of memorizing fluorine and then memorizing chlorine's reactions, Whatever fluorine does, all the other halogens are going to be pretty much doing the same thing. So it alleviates our ability to memorize. We can kind of cut that out a little bit and say, you know what, let's look at this group and let's look at this group and see how they react together. And that's pretty much what we're going to be doing through the rest of the year, is kind of looking at that. Your periodic table should be numbered 1 through 18. So if I say group 18, I'm talking about noble gases. If I'm talking about group 2, I'm talking about the alkaline earth metals. Period 5 would be this, horizontal row, or horizontal, row. Okay? And I think that's pretty much it. Well, actually, you know what? There's metals are on the left-hand side. This stair step here kind of breaks up your metals and your non-metals. Okay? So you have the metals on this side of the periodic table, non-metals on this side. Now you should know what's on the stair step. Along the stair step would be your metalloids. They have properties of metals and non-metals. Okay, so they're kind of like metals, but yet they have some properties of non-metals. They're the metalloids. Aluminum is not a metalloid. It is a metal. So keep that in mind, that this is a metal, not a metalloid. Okay. In class, we'll talk a little bit more about the periodic table and actually have us do a little activity with it. But I think I'm going to end this here. So I'll see you guys later. Thanks a lot.